My name is Govinda Sambamurthy. I'm a head of engineering with Atlassian. I lead the enterprise data portability platform. So when you talk about enterprise data portability, anything that relates to data, data is a new oil, you all know that. With everything that is happening all around you, you want to protect your data. You want to make sure that you deal with compliance with the right amount of seriousness. So my team deals with all use cases related to large scale data movement. And as you know, a lot of us use Atlassian products like Jira, Confluence, Trello, Bitbucket, etc. for collaboration. And all your collaboration data lies in the cloud. And we handle the data movement use cases. So we're going to talk about how do we take care of some of the compliance use cases in the data portability platform within Atlassian, right? So first and foremost, how many of you know what is data residency? Anybody? Show of hands. So we're going to do a quick round of intro to data residency. We'll talk about the architecture. We'll talk about some of the use cases, some of the migration complexities. Then we'll talk about one key scenario which actually took a lot of engineer time. I thought it would be interesting for all of you to know a little bit more into the details about some of the nuances about AWS complexities when it comes to large scale data migration and how did we deal with that. So Atlassian products, Jira, Confluence, etc., have currently support for around 50,000 users, right? Enterprises having 50,000 users in the cloud. You can imagine they produce terabytes of data. When was the last time you ever heard your manager or your CIO or your CTO tell you, please don't file a bug. Please don't write Confluence pages because the cloud cost is increasing. Nobody tells that. Especially in a remote world, in a team anywhere model, in a remote working environment, your collaboration data has zoomed up. How many of you, please raise your hands, how many of you have added more Confluence pages, more Jira tickets, more documentation in the last 3 years? See, so there is an explosive growth of data. While you have explosive growth of data, enterprises are also dealing with challenges around compliance. So we're going to talk about data residency. So a quick show of hands, anybody who knows what is data residency? Want to talk about what's data residency? That's correct. That's to an extent correct. Uh, yes, yes, yes. So you want to make sure that you are compliant to regulatory frameworks. What are the regulatory frameworks? Many of you would have heard of GDPR. There is government regulation called FedRAMP. Then there are industry regulations like FERPA, etc. But the moot point is, our customers, our tenants who use our platform do want to have control over where the data resides. That's the whole idea behind data residency. They might do it for multiple reasons. Primarily, it is from a compliance perspective. It is also from the perspective of, I have a lot of users in a particular area. I want to reduce latency for them, right? But in this context, we primarily talk about compliance use cases. So compliance is a big driver. And the target users for this feature is primarily enterprises and mid-sized companies who have to pay a heavy fine if they don't meet compliance regulation, right? So let's talk about where are we in the data residency journey, right? How many regions do AWS support? Anybody? Anybody in the room? How many regions? I wish that were to be an answer. You're a little off. Anybody else? Okay, I'm hearing wild ranges. The answer is 30, including 2 government cloud, right? So 30 regions. And currently, it's a relatively new concept. Many of the companies which are coming into the cloud are realizing enterprises would trust your infrastructure and your platform only if you support data residency in certain regions. We currently are there in 4 regions, right? Obviously, North America, Central Europe, Germany, and Australia. These are the 4 regions that we are there. We also have a very aggressive plan to launch another 10 regions. You can watch the Atlassian Cloud public roadmap, and you would see another 10 regions coming up in the next few quarters up until 2024. We also support data residency for almost all our products. Jira, Jira Service Management, Confluence, our app ecosystem, we have a framework to actually enable our partners to support data residency, right? So in terms of the physical infrastructure, there are 5 regions that we are there, right? As you can see, US East 1, US West 2, these are single areas called as a realm, right? A realm can span 2 regions. Central Europe, Europe West, and Asia Pacific Southeast, which happens to be Australia. It all started with a Ship It project. How many of you have heard of Ship It in Atlassian? Anybody? So it is a global 24-hour hackathon that we have in the company, which allows engineers to work on pretty much any new idea. And if the idea is great, if the idea can be productized, we allow the engineers to productize that. And many of our products, including the latest product that is out in the market, Compass and Atlas, have all been an outcome of Ship Its. We run it thrice a year. And it's a major engineering fanfare. We love those events. There are lots of innovative ideas that come. So when we started moving to AWS, a couple of engineers thought it would be a cool idea just to take, at that time we had monoliths, right? I'm talking about 7-8 years back, a monolith of Jira and a monolith of Confluence, and deploy it into a new region in Europe. Primarily we were in US. And then we started figuring out that it isn't a big deal. We can actually start supporting European customers just by deploying it into a new region, right? And that is how the genesis of data residency in Atlassian started. But we quickly realized life is not easy, because over a period of time, we expanded in terms of microservices. We created layers and layers and layers of platform. How many of you have multiple platform teams in your company? Show of hands. You know, you have an identity platform, you have a core cloud platform, you have a logging platform, developer tools platform, right? Similar to that, we have a platform that takes care of cloud infrastructure. Our data management is a bunch of layers. Then we do have the enterprise layer. That's why it's empty, because it's an enterprise layer. And then we have 3 product streams. They have their own set of microservices, followed by our app ecosystem. So you can imagine deploying these many services. We have 600 services. Out of the 600 services, for the time being, our scope is any service that retains user-generated content for greater than 30 days. So if there is a data in transit at this point, we don't worry about it, because most of the compliance laws handle data which is persisted for more than 30 days. There are some stricter laws which actually take care of data more than 7 days, but for the time being, we have limited our scope to data greater than 30 days. So in that scenario, imagine what complexity will we deal with if we have to deploy nearly 180 services into a new region. Now, when you talk about this 180 services, not every service would need to be deployed at the same time, right? So we have, over a period of time, evolved what we call as the guiding principles. So there are 3 guiding principles. The fundamental guiding principle, of course, is you got to store your data in the region that your customer or your tenant has asked for, right? You shouldn't assume that the region that the customer comes from and the region that you have to pin your data have to be the same. I have a French insurance company which decided to pin their realms all within Germany context, because 95% of their customer base was based out of Germany, right? And they had to adhere to Germany laws. So you have to give this control in the hands of your tenant. So that's principle number 1. Principle number 2 is, just because you deployed a particular data that actually a service that stores data in a particular region, you cannot actually afford to have a poor latency. So we talked about that earlier. So you need to make sure that your end user experience is not compromised. And then comes the third big constraint. We don't want to be burning cash just because we are deploying in a new region. Now, the third constraint is pretty important because that is not easy. Otherwise, you can take all of your services, deploy it, you don't have to rewire it. Right? So this introduces complexity, being cost conscious, being worried about what is your footprint in the cloud, that increases the complexity. So with that, we actually started talking about what is called as a realm. So we started modeling and defining interfaces and common layers on top of our cloud infrastructure. And that, I believe, would be what you all are interested in, how we modeled multi-region architecture. Right? So if we talk about it, there are three components that we started coming up with. We started defining what is called as a provisioner, a cloud provisioner or CP. CP's job is if there is a tenant that is getting provisioned for the first time, give the control in the hands of the user. Of course, you can make the experience sweeter by defaulting it, by making an intelligent gust, but still give the control in the hands of the user. Let the user choose what region they want to deploy and provision your main service or your tenant ID in that particular region. So that's the cloud provisioning. Then obviously you need to maintain records now. So you need to have a system of records where you would store this tenant ID is going to be mapped to this realm. No prices for guessing that, right? So you obviously need that mapping. So that is your catalog service. Now that is your database. That's your system of record. And you don't want to expose your storage layer to downstream services. So you expose a read optimized view called as the tenant context service. So any service that needs to work on tenant would always look up which region I should work on based on the tenant context service. Now, let's talk about what happens in a data plane, right? I know the picture is not great, so I'll do a voiceover. So let's imagine you've got a request to access a particular Jira ticket or a particular Confluence page, which is localized to Sydney. What happens? Your request from the client, right, maybe a mobile app or an API or even the web page, goes to the reverse proxy. We first hit the tenant context service. The tenant context service behind the scenes goes to the catalog, identifies which is the region or the realm that you have provisioned, returns that back. And then you reconstruct the URL to go back and hit that particular service from the reverse proxy. So the first flow is how a European data would actually flow in if the customer's data is provisioned in Europe. The second one is in US. So as you can see, the server that handles European requests is this one. So you get routed here, and the server that handles US requests is here. Pretty easy. It's simple lookup, right? It's not complex, but we'll add more complexity, right? So this talks about a simple data plane, assuming that you have a new tenant and you're provisioning a new tenant. Now, before we get into more complexity, the moment a cloud infra team makes your region available, you have to have all the services which need deployment in that particular region ready for deployment there, right? Some people call it soaking, we call it service hydration. So service hydration has essentially three parts. Normal SDLC, right? You have to code, you have to deploy, you have to test it. Now when you code, there is a new element that you have to deal with. Your code has to deal with region. So we made region as a first class entity in all our artifacts. So that's what we're going to talk about next, right? So we started thinking about infrastructure as code. We have a layer called Micros, which sits on top of AWS, which is our PaaS layer. Every single service that needs access to the AWS or the cloud infra goes via Micros, and you have a service descriptor. So service descriptor takes region as a first class entity, right? So it's not just services. You've got many more components. Event producers, event listeners, event consumers. So all events need to be routed to the right region, right? You've got kinesis, so you need to make sure that you're not listening to one particular region and sending a message in another region, so you'll have loss. So you shouldn't have that. So that's the second change that we brought in. Third one is, remember, I talked about 600 services in Atlassian, and we are cost effective, and we deploy only 180 services. So there is still 420, right? I got my number right. 420 services which will have to route to the new region. So even in your routing, you have to add region as a first class entity. So the key learning from here is bubble up region or realm as a first class entity. Now there are learnings from here. Even though we have solved a data residency use case, this architecture allows us single tenancy deployment in future. FedRAMP, which is a US government law, that means I want an air bubble environment where only government agencies' data is deployed. This design can actually handle it because we have abstracted region using a concept of a realm, and we are using realm in all our infrastructure config files. So that takes away a lot of the complexity from you. The other part which I have not highlighted, but it's very obvious in the routing is you have always references to logical mapping. You do not ever point to any physical deployment. So you don't go and say server a.b.c.atlassian.com and then say slash whatever, right? You don't do that. Instead, you give a logical ID, and all the deployments actually happen with the logical ID. So your pass layer is what converts your logical ID into the physical calls. So that's what happens here, right? So first part was coding, right? The second part is deployment. Now the big pain, initially when we started rolling out new regions, for example, Sydney, it took us 10.5 months to deploy. We decided to be very optimal. Dev productivity is something which we are very passionate about. So we started integrating and instrumenting into our CI/CD pipeline. We've got multiple CI/CD pipeline. One of that is Spinnaker. So we started automatically provisioning. Anytime a service gets deployed, auto provision your region in lower environments so that you can take care of testing, you can take care of deployments, and all the connectivity, you can check that in lower environments. So that's about deployment. The third part is testing. Now this is pretty serious, right? So what customers are going to do is you're not going to get customers initially deploy in the right regions. No matter what you say, you're always going to have a majority of the customers who will come back and say, hey, guess what? I know I want to provision in Germany, but I got provisioned in Europe. I know I want to provision in Australia, but I got provisioned in US because I thought that my customer base is going to be there. So you still have to plan for a large scale migration. And when you plan for large scale migration, there are two things that you need to test. And it has to be continuous because compliance and your services can change. There are 180 services, one developer, one engineer hard coding region can cause trouble. So you need to continuously test. So what do you test for? You create a test tenant, right? You create a test tenant, you run a few APIs, populate the data, then what you do, you initiate a migration. And we are going to talk about what happens when you migrate behind the scenes in the next slide. You migrate, and when you migrate, you need to make sure that all data for that particular tenant is in the new region. And the corollary of that, no data of that tenant stays in the old region. That's what we test for. So we created a framework called Automated Test Framework, which allows you to rinse and repeat and run test cases every day morning, right, or midnight Pacific time, it gets executed. And if there is a service which has actually provisioned to a hard-coded realm, we identify that and we detect it. So this is how we do it. This is a very good practice that I thought I'll share with all of you. Now comes the migration architecture. Migration can be challenging, right? You need to move tens of terabytes of data. And when you move terabytes of data, you're going to have a lot of challenges. So first and foremost, you need to consider migration as a first class use case. This is a learning that we had, right? We always thought of it as a after effect, but quickly learning from the first region that we rolled out, we decided to provision migration as a first class use case. So in that, we have a new service called tenant placement service. So all your migration requests, either from the customer directly, we have a user interface for that. We also have a support channel through which support personnel can take requests and add it into their interface. Ultimately, your requests go into tenant placement service. So tenant placement service will submit a job. Now here is a deal. Because we deal with data in real time, we want a downtime. It's very important not to have data being written at the same time when you actually start data migration. Even though you can think about optimal solutions about, hey, replication and cut over at the last minute, this is a compliance requirement. The compliance need is as of 10 a.m. PDT, I am data residency compliant. So if you want to certify the timestamp and the date, you got to have a downtime. So during the downtime, what happens is we have a component called per tenant looper. It loops through all your microservices, moves data from realm A to realm B. Now this works like a distributed transaction. If this fails, we roll back the whole change because it's just a copy. We first do a copy. Then if all the actions are successful, we then go back and update our catalog service, which is a system of record, through the cloud provisioner. And after that, the realm has officially moved from US to Australia. There is one step that we still need to do. Can anybody point out that? You have to delete the data. You got to delete the data, and that's the last step, right? So that I have called out in the use case, but it's not very clear, but I think I explained that in the previous slide. You first identify what are the supported regions for a realm, because you don't expose the regions to the customer. The customer doesn't want to know whether I'm in US West or US East. They care only about US for now. But this architecture is scalable if you want to support US East versus West later, because you just need to wrap your realm for that particular region, right? And then you have all the flows, and in the end, once the migration is completed, you delete all the old data. Very easily said and done. But when you deal with customers having 10 terabytes of data, right, having 10 millions of Jira issues, yes, we have customers who have 10 million Jira issues. Jira issue is not only used for tracking bugs. Your release is a ticket in Jira, your documentation is a ticket in Jira, your architecture decision these days are Jira tickets. How many of you use Jira for architecture decision? Yes, many of you use that, right? So your decisions are all tracked in Jira. And in Atlassian, we also use commit tickets, that I'm committing a dependency for an upstream team to be completed by, say, June 2023. That is a commit ticket which we have in Jira, right? Now, the problem is your product data is still okay. You have challenges when you have attachments. How many of you have told, at least in your early career days, to your QA engineer that this is not a bug? And the QA engineer took a screenshot or video and uploaded it and came back and told you, I can replicate it. How many of you have done that? Right? So our attachments are 90% of our data. Right? We do videos, all kinds of videos, huge image files in Confluence, right, and in Jira for handling our collaboration between our users. So when you have 9 terabytes of data of attachment, moving that in a predictable manner is not easy. So we have a separate service called Media, and Media handles storage of all attachments in DynamoDB using chunking. Now, obviously, when you have chunked DynamoDB data, there are problems. What is a problem? How many of you know about WCU, AWS WCU? So AWS in DynamoDB gives you best practices that if you are writing on top of DynamoDB, it's a best practice to have at most 1,000 writes, right? And think of that as 1,000 writes per second, a rate, right? And approximately one WCU is equivalent to writing 1 KB. And we have chunked data, and we chunk data maybe in the size of KBs. Let's start talking about that, right, for simplicity. Now, here you have data that you have sharded. So we use global secondary index, we use client ID as our index, secondary index, and we shard or we partition based on client ID. And because we need to support parallel writes from the attachments or the media service, we also write to media at the same time. We need to make sure that there is a dedicated concurrency to avoid noisy neighbor problem, right? So we have given a concurrency of 9 because the volume of movement of data is very huge. Now, the way we have architected our migration is such that tomorrow the same architecture can also be used if your realm outgrows the original plan and you have to move from one instance to a large machine. That also has the same impact. It's just that you're moving within the same region from one instance to another. So this architecture is very much scalable, right? So what have we done here? So we have indexed based on client ID. The problem with client ID indexing is you will run into noisy neighbor problem. Because at the most I can support a concurrency of 9. So I can have 900 writes and I can have 100 reads on the other side. So if I'm doing this parallelly or writing parallelly from my product, I'm going to get into trouble later. You're almost ready to get a hot or an incident in production. So what we did was, we did what is called as lazy GSI sharding based on a random number. We still use, for migration data, we still use the client ID as the secondary index. We add a random number #1, #2, #3, etc. And we distribute the client media chunked data across all the shards. Okay, so that you can parallelize as much as possible. And when you read it, you don't run into hot. This is yet another best practice that we found, leveraging AWS standard GSIs to circumvent your concurrency problems. Okay, I'll come to the last of it. So with that, we have seen 400% improvement in migration time. So this is the advantage of having the lazy GSI sharding, right? So with that, we go back. We now support a volume of 10 terabytes of data, 10 million issues, and roughly less than 8 hours of downtime, right? So that's the presentation. So thank you for being a great audience here. Thanks a lot.